Starlink is just like any other satellite. There's no difference. No, it's not, and explaining why shouldn't be hard. See, the main difference between the Starlink and other satellites is a lower latency, which basically means less lag. The Starlink does this by having thousands of satellites that orbit the planet much closer to the Earth at 550 kilometers, which lowers latency around 25 ms versus 600 plus ms. When you open the Starlink box, you'll get a base, a 75-foot Starlink cable, a 6-foot power cable, a router/power supply, and who would have guessed, you'll also get the Starlink. To send information, the Starlink antennas, 1,280 to be exact. How does 1,280 antennas hit the Starlink satellites with almost 100% accuracy, you may ask? Well, it's a little thing called phased array beam steering. Fancy, I know. This is done by changing the phase, which shifts the signal left or right, changing the height or amplitude of the signal. This is done by changing the power sent to the antennas, thus making the signal stronger or weaker. The frequency is how many peaks and troughs of wavelengths there are in. 1 second phase shifting is measured in degrees between 0 to 359. Well, let's say we have a signal with 27-degree phase shift or with 120 phase shift. The signal sent to one antenna with respect to the other antenna, and as a result, the timing of the peaks and troughs emitted from one antenna is different from the other. The peaks and troughs move outwards, and the location of the constructive interference is angled where you want, and destructive interference everywhere else. And if we keep changing the phase, the zone of constructive interference changes too. So strong, it can travel 27,000 kilometers per hour. But how does the Starlink know where the satellite is, you ask? It's because of the GPS. The Starlink already knows where the satellite is. So then the information gathered up and calculated to know just how much phase shift is needed. Let's say you wanted to watch Jinxie. How does this send information to this? To watch this. So here's what happens. The amplitude and phase repeatedly changes, and then they assign or encode 6-bit binary values to each change. With 6 bits, we need 64 different permutations of amplitude and phase, but we're only going to do a few. This is a constellation diagram. The further away the number is from the center, aka origin, the bigger the amplitude. And the angle from the positive X angle is the phase. So if the Starlink wanted to send 0000, it will need to increase its amplitude and phase shift, and it will keep changing its amplitude and phase to match whatever 6-digit code it wants to send. These changes last about 83 picoseconds and can have up to 120 wavelengths per symbol in 10 nanoseconds. Before the next symbol or change is sent, meaning it can do 90 million symbols per second, resulting in 540 mbits per second.